All right, so we're going to be talking about more trig functions today, but of general angles anywhere on the coordinate system. And then we're going to move on into the unit circle. Okay, so to do that, you've noticed I don't know if you've noticed, but when I draw my triangles, I always orient them this way. And I always call that theta. The reason why I do that is this. If I have my x and y axes like this, okay? Remember how I generate theta? It's when the positive x-axis rotates upward, right? That's how our theta is generated. So now, suppose I rotate and I make an angle like this, okay? Suppose also that that angle is pointing to a point P. All right, now any point can be expressed in coordinates, right? X and Y coordinates. So take a look at this. Suppose the coordinates for point P are X and Y. Okay, now from the origin, there are a couple of ways that I could go to point P. One is I could follow that ray in red. What would I call a ray like that that points from the origin to any point in space? What's that? What would that be called? It also starts with an R, has a D and an I and a U, and a radius. Okay, so that is called a radius. A radius is any time you draw a ray from the origin to a point in space. We call that a radius. Okay, now, so one way to go to point P is for me to directly go along the radius. Another way to go to point P from the origin, if I could only go horizontally and vertically, right? What would it be? How much would I need to go horizontally? How many units in order to get to that point? X. I would need to go X units horizontally. And how many units would I need to go vertically? Y. Okay? And I make a right triangle here. Okay? So now, if my angle theta is this one, right? Because that's how I created the angle. Now, when I go back to how to find sine and cosine and tangent, and remember I said those were just ratios of the opposite side to the hypotenuse and so on and so forth. You'll see that when I always have my angles drawn this way, so that theta is from the x-axis up to the radius, then I can let go now of that terminology of the opposite side and the hypotenuse and the adjacent side and the hypotenuse. Why? Because if my angle theta is drawn like this, and I have my two legs as the horizontal and the vertical, if theta is always here, okay, which side is going to be the opposite side always? The horizontal or the vertical? The vertical. Okay, so the opposite side to theta is always going to be the vertical because my theta is always next to the x-axis. So opposite side is always going to be the vertical. So then I don't even need opposite and vertical and this and that. All I could use is x and y. So if I wanted to find the sine, would I always be looking for the x or the y? The y. If I wanted to find the cosine, would I always be looking at the x or the y? Yes. The x. So now I could just dump all of that terminology about opposite and adjacent and hypotenuse and horizontal and vertical. Now it's all about the x, the y, and sometimes the r. Right? We're even going to let go of the r eventually. All right? So if I wanted to find the sine of theta, then it would be what over what? What the ratio of which two sides? Y and r. And if I wanted to the cosine, it would be the ratio of which two sides? X and r. Okay? Now we could just free our mind. Okay, like you could free those cells in your brain that are taken up by the terms opposite and adjacent and hypotenuse and this and that. Those are like such baby terms. We don't I don't know what that is. Opposite. What is opposite? It's such a relative term. But I know exactly where y is, it's this. I know exactly where x is, it's this. There's no room in math for those subjective terms, okay? So, I'm not even like, it's not even a, like, it's not even a joke, like math, we can't. Okay. So that's what, and then if I wanted to find tangent, it's the ratio of what to what? Y over X, all right? So the reason why we can do this is because we have a definite way of how we define theta, and it's the angle from the x-axis to the radius, all right? So now we just learned about this, like we understood this now. So I know now that secant is just r over x. I know now that cosecant, which is the reciprocal of the sine, is just r over y, okay? I don't need to sit down and memorize these now because I've understood them, okay? So we need to reason through them like this. Now, let's do an example with this. So we're given a point, -4 and 3, and I'm gonna draw or sketch it this one time. You will find that you really don't have to, but I'll do it this one time. So -4 and 3 will be here. If this is -4 and 3, that's my point. I'll call it P, all right? And my radius to that point is that. And now I have a little triangle here. How much is the x value? So how much do you have to go in the x to reach that point P? -4 units, so 4 units on the left, and then how much do you have to go vertically? 3. Now, how about that r? How about that missing side r? How much is that? Okay, so r is equal to 5. Now, do you have to show me the Pythagorean theorem to get 5? You know what? No. At this point, if you know that 3, 4, 5 is a triangle, let me rephrase that. At this point, you should know that 3, 4, 5 is a right triangle. So don't waste time showing me. Now, if it's something like 19 and 13, and you have to write it out, of course you have to write it out. But for 3, 4, 5s, for 6, 8, 10s, for 5, 12, and 13s, you should know. Yeah.
Okay, for like 19 and 13,
Uh-huh.
I just plug it into my calculator.
If you have, yeah. Absolutely. Okay, so I'm not testing you on Pythagorean. We have bigger things to play with here. All right, so now sine of theta, cosine of theta, and tangent of theta can actually be like simple things to find here, because sine of theta is how much I go vertically divided by the r. So it's what? 3 over 5. Now, and cosine of theta? -4 over 5. Sine does matter, SIGN sine, and tangent? -3 over 4. So you'll see, remember sine over cosine is tangent? And you can just take a look at these. The denominators will go away, and it's just the two numerators. Now, if you look back in the directions, it wants the exact values, so this is good enough. Cosecant of theta is equal to 5 over 3. Secant of theta is equal to -5 over 4. Cotangent of theta is equal to -4 over 3. Okay, I know you can generate those numbers. In this class, I know that you can all generate those numbers. Let's talk about a deeper understanding now. We just said that sine is associated with which leg? The horizontal or the vertical? The y or the x? Sine is associated with the y. Okay, the y-axis. Now, my point is here, yes? Now, in this region, is the y-axis positive or negative? The y-axis in this region is positive. In this region, is the x-axis positive or negative? Negative. So my point P is in a region where the y is positive, the x is negative. Is that correct? That means all of my trig functions that are associated with the y are going to be positive. Like sine is just the y, it's going to be positive. Cosine is the x, it's going to be negative. You see that? Tangent is the y divided by the x, positive divided by negative, it's going to be negative. Okay? So again, if we think about it this way, then we don't have to sit there and memorize all students take calculus. We know, oh yeah, here the sign, it's the y-axis. Y is positive, x is negative, da-da-da-da-da. Okay. That leads us to quadrantal angles. This is only some of the time that an angle can land there. There is a huge amount of chance that the angle will land on either the x-axis or the y-axis. In that case, we call those quadrantal angles. So when the terminal side lies on one of the axes, we call that a quadrantal angle. All right. So let's take an example where my angle is 0 degrees. When my angle is 0 degrees, my terminal side is on the x-axis, the positive x-axis. So this is an example of a point. Now, who can give me a coordinate point that could possibly qualify as the coordinate of that point? 4 is not a coordinate point. 4, 0 would be one. Whoops. What else? 5, 0. And what's the smallest number I could use? 1, 0. You'll find that it really doesn't matter what number you use, whether it's 1, 0 or 4, 0, but you'll find that, ones are always simpler. So now, if that point has coordinates 1, 0, remember how we defined the radius? We said the radius was the distance from the origin to that point. How much distance is there if that coordinate is 1, 0? 1. So R is equal to 1. How much distance is there from the origin to that point? There's a distance of 1. Yeah.
Okay. Does R always equal the horizontal side in quadrantal angles?
No, it could also equal the vertical side. It equals the length along the axis, yes. The distance along the axis. Okay, so now, if I wanted to find the sine of 0 then, remember I just said sine, is it with the vertical, the y distance or the x distance? The y distance. So how much vertically do I have to go up to go to that point? 0. So since sine is 0, y over r, it's just 0. Okay? Cosine, how much do I have to go horizontally to get to that point? 1. Now, it's divided by the radius, which is how much? 1. So it's 1 over 1. Okay? So cosine is the distance in x. From here to here, I go a distance of 1 in x. How much is the radius? It's the same. It's 1. Okay? So I get 1. Okay, so how much is tangent? Tangent. It's how much I go in the y over the x, 0. Okay? How about cosecant then? Cosecant, I hear undefined. Cosecant is 1 over 0, 1 over the sine. So it's got to be undefined. How about secant? 1. And what about cotangent? Undefined. All right? Now, let's do another one. What if we're at 90 degrees? I have an angle there. What could be a qualifying coordinate point there? 0, 1. So, it's 1 up on the y-axis. Now, how much is the radius to there? 1. The radius is always going to be 1 if you choose your points as having coordinate 1. So, it makes it so much simpler because you're just dividing by 1. And it's just easy to do. So now, how would you find the sine of 90 then? It's how much you go in the y, which is what? 1. Okay? Do I even bother with the radius? Do I even bother with the r? You're just dividing by r, which is dividing by 1, so don't even bother. So when I think about it, when I, Miss Malikan, when somebody asks me, what's sine of 90? I say, oh, that's 1 unit up, so it's 1. When somebody asks me, what's sine of 0? I say, oh, that's 0 units up, so it's 0. What's cosine of 0? Okay, cosine is the x. I go 1 over in the x, it's 1. What's cosine of 90? How much in the x do I go there? 0. So cosine of 90 is 0. I don't even bother with the r. So what's tangent of 90 then? Undefined. Now let's do the other three, and then with the other two angles, I'm not going to go into this much detail. What's cosecant? 90. 1. What's secant 90? Undefined. What's cotangent? 0. All right. So for 180, here's my point. What's a coordinate point for 180? Negative 1 comma 0. So now, what would the sine of 180 be then? Sine is associated with the y-axis. 0, because to get to that point, I go 0 up. What's the cosine of 180? Negative 1. It would be negative 1 over... The radius is always a positive 1. It's an absolute value.
Isn't it just the same thing as 0 degrees except for the positives or negatives?
Yes. Okay.
And same thing with 270.
Mm-hmm. Okay. So, if you have questions on this, what are you supposed to do? Come to bonus. Come to bonus. Okay? All right, so let's take a look at this. It says to find the exact value of each trig function. So I have 7 over 2, right? 7 pi over 2. How many pi is that? Is it 3 pi?
3.5.
It's 3.5 pi. So these are, over here, are your even pi's. Look, 0 pi, 2 pi, 4 pi, 6 pi, 100 pi, 252 pi. These are all your odd pi's. 1 pi, 3 pi, 5 pi, 51 pi, 343 pi, all here. So 3.5 pi, 3, and another half pi, I'm right there. Okay? And I need the cotangent, right? So what's the x-coordinate there? 0. What's the y-coordinate there? Negative 1. And since this is x over y, how much is the cotangent? It's x over y, 0 over negative 1, so it's 0. Okay, so remember, if you have 0 pieces of chocolate and you're going to distribute it among 5 of your friends, how many does each get? 0. If you have 5 pieces of chocolate and 0 friends to distribute it to, that's not cool. So that's undefined. Okay? All right. So think of it that way. If you have 0 things to distribute, that works. If you have 5 things to distribute and nobody to give it to, that doesn't work. All right. One more. Tangent of 450. Where is 450? If 360 goes back there, where's 450? It's up here. What are the coordinate points there? 0, 1. So what's the tangent there? Undefined? I have an undefined. It's 1 over 0. Okay? Alrighty. Let's talk about reference angle. A reference angle is always the angle between the x-axis and the terminal side. Or, I like to say it, it's the acute angle. So a couple things about reference angle. It must be acute. Acute means 0 to 90. That takes care of positive, negative. 0 to 90. It has to lie between the terminal side and the x-axis. Now, I'm going to go a little bit further here. Here, I'm on the terminal side. And I need to go to the x-axis. There are 2 ways I can get to an x-axis. I can go downward to the right, or I can go to the left. Which one is the closer route? To the right. That's the reference angle. So I always say it's the angle between the terminal side and the nearest x-axis. Okay, the nearest x-axis. So there. So if I have, let's say, an angle of 50 degrees, that's just its own reference angle. Now, suppose I have an angle of 160 degrees. Okay, let's draw an angle of 160 degrees. There it is. Now, the reference angle is here. So it's the balance. How much would I have gone to make it a straight angle, 180 degrees? But how much did I stop short? By 20. So that's 20 degrees. So always reason through it. When you do that, you don't have to bother with the stuff that the book comes up with. Okay? Yeah, it's mathematically correct, but who wants to sit there and memorize any of that? All right? So if I had an angle of 210 degrees, here, what would be the reference angle? How much? 30, right? If I had an angle of 310 degrees, how much would be the reference angle? 50, because that's how much more I have to go. So if I have an angle of negative 150 degrees, right? How much would be the reference angle? 30 degrees. It's always an acute angle between 0 and 90. Never negative, always positive. Okay? And theta prime is the symbol we use for reference angle. All right. 3 pi over 4. Okay, so look, we all know where 3 pi over 4 is. This is 3/4 of a pi. So, like right there, you don't go a full pi, you go 3/4 of a pi. But it's actually easier to find the reference angle for a radian angle. Why? Well, not even. Not even. Whatever the denominator is, it's just pi over 4, blindly. So if we had 11 pi over 6, what's the reference angle? 21 pi over 3. 81 pi over 4. Okay, yeah, as long as like it's a simplified fraction. Like 81 pi over 3, that's not a simplified fraction, so that doesn't work. But a simplified fraction like 15 pi over 4, that's it. You don't even have to think about it, right? Those are like free bonus points, okay? So, now if you had any random angle, okay, 480 degrees, and you wanted to find the trig function of it, sine of 480 degrees, whatever it is. It's a 3-step process. 1, find the reference angle theta, okay? Find the value of the trig function for theta prime, and then fix the SIGN sign. All right, now, before I go through these, well, I sort of touched on this, right? All students take calculus. This tells you if you have an angle in, let's say, the 3rd quadrant, is the sine of it going to be positive? Is the cosine going to be positive? Is the tangent going to be negative? So it goes by all students take calculus. Can somebody explain how we read this? So what does it mean that there is an S here? Yeah.
So you look at the positives. So the quadrant 1, all of them are positives. So it's all, and then is positive, only the sine is positive, and quadrant 2, only the tangent.
Right, and only the cosine is positive there. Also, remember, this in this quadrant, x is positive, y is negative. X is cosine, it's positive. Everything else must be negative. Okay, before I do this, let me go on. Let me do a little bit on the unit circle, and I'm going to come back. Okay? All right. We said, I know I've mentioned this before. We said that if you have a 30, 60, 90 triangle, that the ratios, if the short leg is 1, this is root 3 times the short leg. This is 2 times the short leg. Well, fine. But on the unit circle, is that a radius? Is this a radius of the unit circle? In a unit circle, how much is the radius always? 1. So if that's 1, this triangle can't fit here because that has a length of 2. That means I have to rescale my triangle. So now, there's no longer 1 and root 3 and 2. It's always a short side with a 1/2, a long leg with a root 3 over 2. All right, so now, this is an angle of how much here? 30 degrees. So, if I wanted to find the sine of theta, sine of 30, is sine the y or the x? The y. So, again, here's how I, Miss Malikan, will do this. If somebody asks me for the sine of 30, this is how I do it. I'll run you through my reasoning. Okay, 30 degrees. Between 30 and 60, that's the small angle, faces the small side. So if I want sine of 30, that's the vertical, that's the y, that's the smaller one, that's 1/2. If I want a cosine of 30, I say, oh, 30 faces the small side, this must be the long one, √3/2. All right, so let's do this one here. Cosine of 120. So first we find the reference angle. How much is the reference angle for 120? 60 degrees. Okay, where is 120? Which quadrant, by the way? It's the second quadrant. I'm not even going to draw the angle. I'm not going to draw a triangle. I'm not going to draw anything. Okay? Yes.
Wouldn't it be 30 to get back to 90?
But how do we define reference angle? Terminal side and the x. Always x. The y-axis in trig really takes on a secondary role. Okay? So now I want to say, what's the cosine of 60 degrees? 60 degrees, that faces the larger side. The cosine must be the smaller one of 1/2. Now, is my answer going to be positive or negative here? How much? Negative. So it's negative 1/2. Okay? Now, if you haven't already done so, go ahead and do the other two. I will pause this for a sec. Struggling with this. Okay, let's move, this way. All right, let's do this one. So what I have here is that the secant of theta is √21/3. Okay? What we're going to do is we're going to draw a triangle with this. Again, it's convention. I always draw my angles oriented like this. It's consistent with how it looks on the unit circle. Now, secant is hypotenuse over what? Opposite or adjacent? Adjacent. So it's hypotenuse over adjacent. Meaning, the hypotenuse of this triangle gets a √21. The adjacent side to theta gets a 3. Now, is there any way we can find that missing side x? Pythagorean theorem. So 9 plus x squared is equal to 21. So x squared is how much? 12, and x is 2√3. Now, I'm also given one other piece of information. I'm told sine of theta is positive. All right? So, in which two quadrants is sine of theta positive? Here and here. Now, what about the secant? Secant is positive √21/3. Where is that positive? Here and here, right? Okay, so the quadrant where both of them match is quadrant 1, so all my answers are going to be in quadrant 1. That means the other trig functions are all going to be positive. So let's find then sine of theta. Can we do that? It's 2 root 3 over root 21. And look, you could simplify those. And it'll be 2 root 3 over 21. So that's just 2 over root 7. Right? Huh? Huh? Right. So then it'll be 2 root 7 over 7. Okay, I'll talk about rationalizing next time. Okay, cosine of theta is going to be 3 over root 21, which is equal to 3 root 21 over 21, which is equal to how much? Right. Okay, tangent of theta, 2 root 3 over 3. All right. Now, cosecant of theta, I take the reciprocal of 1 step over. That's the easiest one, and there's no roots to deal with. Secant, I'm already given. Cotangent of theta is how much? 3 over 2 root 3, which is 3 root 3 over 6, which is root 3 over 2. Okay? Makes sense? Okay. So, for next time, please do the homework from page 59 up to and including the, this every other odd. So it's 9 to 31 every other odd, and then 47 to 57 every other odd. Now, if you find that you start with 9 and then you get to 31 and that's not one of the every other odd ones, that's fine. Just like stop wherever it ends. Okay? So that'll be due tomorrow.